In this part, we're going to simplify the square root with numbers and variables. So in our example here, we have the square root of 12a to the 6th power. Before we get into the work of simplifying the square root, I want to talk about parts of the radical. Now, you heard me call this the square root. Now the reason is based on the index. The index is located at the top right of the radical. So since we call it the square root, it's because there's an invisible 2 at the top left. Now, when you see a radical with no numbers at the top left, meaning no index, then you can call it the square root. But if there is a number, then you have to call it by the number it has. So if it's a 3, cube root. If it's 4, the 4th root. If it's 5, the 5th root, and so on. But here, we call it the square root because, again, originally you didn't have a number at the top left. But it's an invisible 2. So you can label the 2 when you're simplifying radicals with numbers and variables. So let's start off by breaking the number and the variable apart. So we're going to have the square root of 12. And I'm going to include my index. Alright, let's focus on the number first. The square root of 12 is not a perfect square, so we're just going to break it into two numbers, which is 4 and 3. And then for the variable, now you're going to compare the index with the exponent that's inside the radical. So basically my question is, can the index, the 2, go into 6 as a whole number? Which it can. So I'm going to first leave it like this as the square root of a to the 6th power. And then I'm going to focus on simplifying the parts that I have down here. So the first one, the square root of 4, it's a perfect square, which will become 2. You can't do the square root of 3, so it stays the same. And it's multiplying. Now for the square root of a to the 6th power, 2 can go into 6 3 times. So I'm going to write a to the 3rd power. Since 2 can go into 6 3 times, then the exponent on the a is 3 without the radical. I finished simplifying. Now I'm going to put the numbers and the variables in the front that does not have the radical. So 2a to the 3rd power. And then what I'm going to put next is the one that has the radical, which is the 3. So that is our final answer. Let me box that up. So our final answer is 2a to the 3rd power square root of 3. To review, I broke up the number and the variable separately, broke up the 12 into 4 and 3, and then for the variable I didn't do anything because I checked the index, the 2 can go into 6 3 times. So when I'm simplifying, I did the square root of 4, which is 2, and I simplified the square root of a to the 6th power, where 2, the index, can go and go to 6 3 times, hence we got a to the 3rd power. And then the square root of 3 can't do anything, so that's left alone. So I'll put everything that's without the radical, the 2 and the a to the 3rd, in the front. And then I put the square root of 3 because it has a radical, I put it in the back. So our final answer is 2a to the 3rd power square root of 3. So the next example, we have the square root of 20 m to the 11th power. Like I said before, if you do not see a number at the top left, that means that the index is an invisible 2. Now I'm going to split the number and the variable apart. So we're going to have the square root of 20 times the square root of 11 to the 11th power. Alright, so just like before, I'm going to break up the 20 into two numbers because 20 is not a perfect square, so I cannot do the square root of 20. I'm going to simplify into two numbers, which is 4 and 5. Where the perfect square number, the 4 is up front. Next, I'm going to check my index. Can 2 go into 11 as a whole number? It cannot. So what I'm going to do, just like how I broke up the 20 into two numbers, I'm going to break this m into two m's. Now, what I'm going to do is I'm going to count down from 11. So from 11, if I decide to take 1 away, I have 10 left. Then my next question is, can 2 go into 10 as a whole number? In that case, yes. So, since I took 1 away, I have 10 left. So I'm going to put the 10 on the first m. And then the amount that I took away, which is 1. So, the reason I did this is so that 2 can go into 10, whereas 1, it cannot. So we broke up into two m's, so that way parts of the m, in this case the m to the 10, can be simplified. So we're going to have the square root of m to the 10th power, while we have the square root of m to the 1 power. And then again, double check, the reason I got 10 and 1 is because these two exponents can add up to 11. All I did was broke down the m to 11 into two m's, where 1 is m to the 10th power and m to the 1 power. Again, the reason I did this is so that we can simplify parts of the m. Now, let's talk about simplifying. The only thing that I can simplify or do the square root of for the number is the square root of 4, which is 2. Now, the square root of 5, I can't do it, so it stays the same. Now for the variable m, I can do the square root of m to the 10th power because 2 can go into 10 5 times. So I'm going to write m to the 5th power. So I repeat, I can do the square root of m to the 10th power because 2 can go into 10 5 times. Hence we have m to the 5th power. Now 2 cannot go into 1, so it will stay in the same, meaning I'm going to have the square root of m, or square root of m to the 1 power. Now in the final phase, you don't have to write the 1 power, you could just leave it as m to the invisible 1 power. Next, I'm going to write all the parts that does not have the radical, the 2 and m to the 5th. So I'm going to have m to the 5th, 2 m to the 5th. Then I'm going to put everything that's with the radical, the 5 and the m, but I'm going to put it together, meaning 5m will be inside one square root, just like that. And then I'm going to box my answer. So here's my final answer, 2m to the 5th power, square root of 5m. In this example, we have 5, the square root of 18a to the 23rd power. Again, I said the square root, so meaning that my index of this radical is the invisible 2. So first, we're going to break it into the square root of a number and the square root of the variable. So I'm still going to have the 5 in the front, but now I'm going to have the square root of 18 and then the square root of a to the 23rd power. Now just like before, I'm going to break up the square root of 18 because 18 is not a perfect square number. We're going to break it down where 1 number is a perfect square. And again, I still have the 5 in the front. Now over here, I'm going to have the square root of 9, because 9 can go in 18 two times. Then for the variable, my question is, can 2 go into 23 as a whole number? In this case, it cannot. So what I'm going to do, I'm going to break it into 2 a's. Now counting down from 23, if I take 1 away, I have 22. 2 can go into 22 as a whole number, so I'm going to write 22 here, and the amount that I took away, which is 1, I'm going to put it on the second a. So I'm going to have the square root on a to the 22nd power, and also the square root on a to the 1 power. Alright, so let's start simplifying. Like I said before, we still have the 5 in the front. Here I can do the square root of 9, which is 3. So I'm going to bring down to 3, and it's multiplying. Now the square root of 2, I can't do the square root nor simplify, so I'm just going to bring it down. Now for the variable part, I can do the square root of a to the 22nd power, because 2 can go into 22 11 times. So I'm going to have a to the 11th power. 2 cannot go into the 1 power, so I'm just going to bring down the square root of a. Just like that. From there, I'm going to do 5 times 3, which is 15. I'm still going to have the square root of 2. And I'm still going to have the a to the 11th power times the square root of a. So just like the last example, I'm just going to put the ones that without the radical in the front. So 15 a to the 11th power, and then the one with the radical, I'm going to put it together but inside one square root. One square root. So here is my final answer. So it's 15a to the 11th power, the square root of 2a.